Welcome everyone. In this video I'm going to talk about the ADS1256 AD converter in a bit more detail, and in this video I'm going to show you how to read the registers and how to write the registers with an Arduino. I will not show the whole code, but I will upload the source code or the part of the source code which is corresponding for the reading part and the writing part. But in the video I'm going to focus on the understanding of the sequence of steps. So I'm going to show you how to understand the datasheet and what is written in the datasheet, so you can write your own code for this kind of device, or even for other devices which require similar reading and writing procedure. So I copied out some details from the datasheet. You can just Google the datasheet, but I will put a link in the description. But on page 34 and 36 you can see some very useful details that you can use to read the registers. So what you can see there, that small piece from a table is basically the byte which is used to read from a register, and on the picture you can see how you can use the command bytes and how you can receive the data. So let's just go through everything. So first of all we have d_in, which is basically the data input. So this data which is coming from the Arduino and received by the ADS. So this is received by ADS. And then we have d_out, which is received by the Arduino, just to understand the directions. And then what is again important on this kind of image is this, the timing. So what is the time which should elapse between the d_in command sequence and the d_out, and that is T6. And if you look up the datasheet, that basically means that you have to wait at least 50 tau, so 50 times tau, and this is clock in, where this value is basically derived from the frequency of the oscillator on the board, which is in this case is 7.68 megahertz, and then this is then roughly 130 nanoseconds. So if you do the math up here, this is 6.51 microseconds. So let's say it's roughly 7 microseconds, because when you try to delay within the Arduino you only can use integers, so we will use 7, or you can use higher, but at least you have to have T6 time, which is this, between the writing of the registers and the reading of the registers. So let's see what we do. So let's write steps. So when you want to read the register, first of all you have to wait for the data ready. So we wait for the data ready, and when this goes low, then that means we can work with the register. So we wait for this, and then the second is we have to initialize the SPI, and that goes by this command like spi.begin transaction, and then you give the speed, and you give which bit, most significant or least significant bit comes first, or byte, sorry, and which mode of the SPI you will use. I don't go into details, but you will be able to check in the description. There will be a link and you will see the code itself. I just want to see and want to show you the strategy. So we start this, and then we can add a delay here. So we just wait a little bit, but here it's not yet necessary. And then we have to pull down the chip select pin. So the chip select, or sometimes it's SS, so this will be low. So this tells the device, the AD converter, that we are going to do something with it. And then we start our transfer. So basically we do an spi.transfer and in the argument of the transfer there will be 2 command bytes, as it is written up here, right? So what we do here is the first one is 0x10, which basically means that we are reading a register, and then we would like to use the address of the register. So simply I just now write here address. So that's all, and the address here now is 1. So if we try to do this, this is basically a bitwise operator here, this. So this is a vertical line. And what this tells is basically the following. So if you want to see this bit in a bit more, or byte in a bit more details, so the first part of this is this, which basically means in decimal is 16, or if we want to write all the binary, so we have this, sorry, and one more here. So this is the first part, and then the address is 1, and that is obviously more simple. This. And if we use the operator, then we just have to put these 2 guys on top of each other, and then just where you have 1, you just write 1. And that's the result. So this was fairly simple. So this will be in this parenthesis. So we have this done, and actually you can see that in the first command byte we have that as a result. We can go to the next. So what we do here is again an SPI transfer and 0x00. So we just write full zeros because we just want to write one register at the same time. So it doesn't really matter if you write 0 here. So you can do this, and then we can wait a little bit. So we delay again, and the delay should be the T6. So let me write it down here. And then let's say we have a variable which says that this is the register value, and that will be equal with the transfer this. Why this? So what we do here is basically we shift out the register by writing to the SPI, and what this number is basically 255. So what we do is this. So we just shift out all the values in the register with this guy here, and what we shifted out will be end up in the reg value variable. So we will see the value of the register that we were reading. And then finally we have our result, so we just have to finalize our procedure. So we go back. We can delay a little bit here again, and then the chip select or the SS pin should go high, so this will indicate that we finished the transaction, and also we have to end the SPI transaction. So SPI dot end transaction. So that's all. So this is just the algorithm, and I wanted you to understand what we are doing with the numbers here. And this is how you read the register. So once again, we wait for the data ready, and then we initialize the SPI, we wait a little bit, and then we switch off or pull down the chip select pin, and then we write to the or send a message to the AD converter by combining the read register command with the address of the register, which is demonstrated here, and we send that to the ADS device, and when we wait a little bit, we will be able to shift out the result, so the value of the register, and we will be able to store it in a variable. And after that we just conclude our procedure by pulling up the chip select pin and end the transaction, and that's all. So if we have a register that we want to read, for example, we want to see what is the data rate of the ADS1256, then we can just make our command by selecting the register and selecting the command by this, and selecting the register and sending it to the ADS, and that's all. So now we have to know how to write the registers, because reading is simple. So let's see how to write. So these are again from the datasheet, and then let's write down the steps. So the first step again is we wait for the data ready to go low, and then again we start the transaction, so SPI dot begin transaction, and then we write some details here, and then again we pull down the chip select, and then we wait if we want, and then we go again with these two guys here. So we have 2 command bytes, so the first byte will be that, so spi.transfer, And then now we have this command here, and then we have again this address. So first of all, this is the wreg command, so we want to write a register, and then this is the address of the register. So first we have to select which register we want to write. So this is nothing fancy. So if you want to do, or if you are interested, then this is 80 in decimal, or in binary you can do like this. And then let's say we want to select the D rate, so the data rate register, and then that is 0x03, which is in decimal is 3, or in binary it is very simple, 3. So we have the first command byte here, and this is also basically the first. So just to understand, if you see the first command byte is there, and we had the wreg, which is 80, and then we have the D rate. So this is 0, 0, 0, 0, 0, 0, 1, 1, and then we just use the operator, this vertical line basically, which is here, and this means that wherever we see a 1, then that column becomes 1. So if you see this number here, it should be identical to this 0, 1, 0, 1, that's done, and 0, 0, 1, 1, 0, 0, 1, 1. So in the datasheet or the handbook of this ADS1256, the first command byte means that we want to write the register and we want to write the D rate register, and it's written here as well, so it's quite obvious. And then we just shift in the data, so 0x00 in the next step, and then we wait again, a bit again, let's say T6, and we initiate again another transfer because we want to write a value to this register. So let's say spi.transfer, and then value. And then what you can do here is you can write in hexadecimal or decimal or binary. Let's choose a binary, and to practice we want to write this number here, which is 35 in decimal, and this is corresponding to the 10 SPS setting. So we did this, and then the final steps is we pull up the chip select or slave select, and then we just end the transaction. So this is very simple. So again, we wait for the data ready, we start the transaction and tell the chip that we try to do something with it. So we pull down the chip select and wait a little bit, and then we start our first transfer by telling what we want to do and on which register we want to do something. And then we combine these two numbers with this operator. And we have our result, so this will end up here, but you can program it like this, so you have this as a basically a constant number, because this is always, if you want to write a function which writes the register, this will be permanent here, and then you can handle this as an input from the terminal, for example. So then you combine these two numbers and transfer it to the ADS. You wait a bit, and then after you told the chip that you try to write the third register, which is the D rate register, then you want to also set it to a certain value, and that happens in the sixth step here. So we define that value, and we just write either this number or 35, and the chip will know that, alright, if we have 35 in the register 3, that means that the data rate will be 10 samples per second. And we just conclude here by pulling up the chip select and ending the SPI transaction. So this is also very simple, and you don't need too many things here. In the reading register, you just need the address of the register, but here you need the address of the register and the value of the register, and that's all. So I will include two separate parts of the code, two functions basically, which is the writing and the reading of the register, and you can try to build up your own code if you want, or you can wait for my future videos where I will build up a whole source code for this kind of controller and for this kind of AD converter, and then you can use the final code to have some fun with this chip. And I think that's all. So I hope you learned something from this video and it was useful to a certain extent, and you understood more about this kind of microcontroller and this kind of AD converter. So this is all, and see you in the next video, where I will talk about the data acquisition. So I will show you how to obtain data from the ADS1256, how to write the code as well. So see you there.